Today in class, we looked at some properties of special right triangles. And given these two examples of a 30, 60, 90 and a 45, 45, I showed you guys how you can solve for each of the parts or sides of each of these triangles using a shortcut. Let's start with the 30, 60, 90. The Pythagorean theorem proves it. If you have a 30, 60, 90 right triangle, it's actually like taking a equilateral triangle, like the one that we have here on the right, and then cutting it in half by using the altitude. And what the result is this right triangle that's 30, 60, 90. Now, let's say that we are given lengths of the equilateral triangle. Let's say that each side was 2. Well, since this right triangle was taken from that, then we'd have the hypotenuse as 2 as well. And we'd actually have this side as 1. Because when you take the height and you cut, remember I said you cut the triangle in half with the height, then half of that side is going to be 1. Now, let's see what we can do by using the Pythagorean theorem. We can say that this height of the equilateral triangle is going to be 1 squared plus h squared equals 2 squared. And then the height squared is going to be 4 minus 1. And then take the square root of both sides, and you get that h is equal to the square root of 3. And so you get this property in any 30, 60, 90 right triangle. The short side, let's call it x, times radical 3 is going to be the long leg, and times 2 is going to be the hypotenuse. Let me show you what that means. Let's take a couple examples. Let me just shrink, if I shrink both of them, okay. Let's look at the one on the right first. Now, I know that the acute angles are complementary, and so that angle is going to be 30. And so the short leg being 3 means that the long leg is 3 radical 3, and the hypotenuse is 2. Okay? Now, slightly different, instead of 3 being across from the 30-degree angle, let's say it was across from the 60-degree angle. How would that change things? Let's take a look. We would have that we need to find the short leg. So we're going to call that x. Okay? So 3 is going to be equal to x times radical 3. Then we would need to divide both sides by radical 3, and we get that x is equal to 3 divided by radical 3. But you see, you can't write a radical in the denominator because that would be like dividing by an irrational number, and that's just not in simplified form. So we have to multiply by a 1 that represents the radical. Now, if you want to know some more information about how to rationalize the denominator, we're going to talk about it a little bit in class, and I've also put up a video. So what happens here is we end up with x is equal to 3 radical 3 over 3. and so x is equal to radical 3. Then we know that since we have a short leg equal to radical 3, twice that short leg is going to be the hypotenuse using the rule of the basic rule of the 30, 60, 90 right triangle is the leg, short leg, the long leg is the short leg multiplied by radical 3, and the hypotenuse is twice the leg. In this problem, we're going to be looking for the height of an equilateral triangle. I went ahead and used A as the variable to not get confused with H to stand for hypotenuse. I thought that might be confusing. So we're going to say A is the altitude. So we're looking for the altitude of an equilateral triangle. We're given that the sides are 3 and 3 and 3. And we know that by the properties of an equilateral triangle, this is also equiangular. And so each angle is actually going to be 60. And the angle up here is actually bisected, as I demonstrated earlier. Now, with the properties of special right triangles, we know that a leg opposite the 30-degree angle is going to be multiplied by radical 3 in order to get a long leg, and multiplied by 2 to get the hypotenuse. So in order to do this, everything is based on the short leg. And so no matter what problem you're working with, you're going to want to start with knowing the short leg. And you're going to have to find it if you're not given the short leg. And so here we can see that if we look at the hypotenuse, 3, and divide by 2, or even if we look at the leg, or the other side, and divide by 2, we're going to get that the short leg is 3 radical 2. Now let's apply the properties of special right triangles. In a 30, 60, 90 right triangle, the short leg multiplied by radical 3 is equal to the long leg. Now, some of you guys might still need a little bit more extra information. So I'm actually going to show you how we can do this by using the Pythagorean theorem as well. So let's move this out of the way. We can still see that. And we're going to be looking at a triangle that has a short leg that's equal to 3 halves, a hypotenuse that's 3, and we need to find the long leg. So let's do 3 halves squared plus a squared is equal to 3 squared. 9/4 plus a squared is equal to 9. 9 minus 9/4 is equal to a squared. And when we do 9 minus 9/4, that's the same as 36/4 minus 9/4, and so we get 27/4 is equal to a squared. We're going to have to take the square root of both sides. I'll continue the work. A squared is equal to 27/4, and we have to take the square root of both sides. So A is going to be equal to the square root of 27 divided by 2. Now 27 has a factor of 9 and a factor of 3. And so 27 in simplified radical form is 3 radical 3, and then you have to divide the whole thing by 2. Now if you remember, at the previous slide, we had that the altitude of the equilateral triangle was 3 radical 3 divided by 2 when we applied the properties of right triangle of special right triangles. Let's look at an isosceles right triangle. The Pythagorean theorem also proves the special property of isosceles right triangles. Let's try this for an isosceles right triangle that has one leg that's equal to 1. 1 squared plus 1 squared is equal to the hypotenuse squared. 2 is equal to the hypotenuse squared, and so the hypotenuse is equal to radical 2. So in any isosceles right triangle, or 45 degree triangle, right triangle, we have that each leg multiplied by radical 2 is going to be the hypotenuse. Now some examples would be, in a 45 triangle, we have the properties of each leg is the same and the hypotenuse multiplied by radical 2, the leg multiplied by radical 2 is the hypotenuse. Let's look at another one. It's related. We can see we have an isosceles triangle, so that means that we have 45 degrees. We have a hypotenuse that's 2, and we want to know what the legs are. Let's call that L for the unknown leg. Well, a leg multiplied by radical 2 is equal to the hypotenuse. So we're going to divide by radical 2. We have that L is equal to 2 divided by radical 2. Rationalize the denominator. Again, I have another video to demonstrate that. And we get 2 radical 2 divided by 2, and so L is actually equal to radical 2. So here's your extra credit problem. Using the special right triangle properties, I want you to find the area and the perimeter of this quadrilateral. Have fun. Email me your answer by the beginning of next class.